Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel Foundation Tier Paper 3 from 2019 and we're covering all the questions, so if you find this helpful please consider hitting the subscribe button. So question 17 is a question where we've got an accurate scale diagram that shows the telephone mast and the box, and what we've got to do is we've got to estimate the real height in meters of the telephone mast. So here's our telephone mast here, and we've got to estimate what the real height of that would be. So because it's an accurate drawing, what we've got to do is we've actually got to get a ruler for this, and so I've got this one on my desktop. Obviously you'd be working on paper, so you'd be using a real ruler for yours when you'd be doing it. So what we need to do is we need to measure this distance here. So I can see that's 2 centimeters, and so from that what we can say is that 2 centimeters is equal to the 1.5, or represents 1.5 meters. So because we know that, we can actually then find out what 1 centimeter would be worth. So 1 centimeter, if I divide both sides by 2 to get from 2 to 1, I've got 1 centimeter on that side. And if I divide this side by 2, I could use my calculator. I will do, just because in case it was a more complicated calculation, but I'll just go 1.5 divided by 2. And so 3/4, and just press the SD button there, and it gets us a decimal. So we can see that 1 centimeter on our diagram represents actually 0.75 meters. So the next thing that we need to do is move our ruler, and we need to measure the height now in centimeters. I'm going to have to just change this from that stands for pixels on this one. So we're just going to move this here and measure the height. So I can see that on my diagram, I'm going to say that's 11.1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 11.9 centimeters, and so if 1 centimeter equals 0.75 meters, then 11.9 centimeters is going to be equal to go from 1 to 11.9, I'll have to times by 11.9. Just get rid of these. So I have to times by 11.9. So I've got to do the same to the number of meters that represents. So times that by 11.9 as well. And so I'm going to take me 0.75 and times that by 11.9. I'd get away with saying that was 12 actually, because it's not asking for perfect accuracy. It's more interested in the technique that we're going to use. So if I do that, again it's given me as a fraction, which we don't want. We want it as a decimal. So I just press the SD button there, and I get 8.925 meters. 925 meters. So that's our estimate for the height, the real height of the telephone mast. Moving on now to question 18. What we've got is a frequency table. So this is telling us information about the number of points scored by 30 students in a quiz. So what it means is that the number of times no points was scored was going to be 4. So 4 students didn't score any points. That's that first piece of information. And then we can see that 3 students scored 1 point, 7 scored 2, 5 students scored 3 points, 6 students scored 4 points, and 5 students scored 5 points. And in fact, if we added this column up, we would find it would come to 30. 4 plus 3 plus 7, 14 plus the 5, 19 plus 6, 25, and then another 5 makes 30. So if we added that column up, that would actually make 30, which is the total number of students. So what we've got to do is we've got to find the modal number of points, and the modal number of points means the number of points which occurred the most often. So mode means most often. And in this case, it means the one that's got the highest frequency. So the one that occurs the most often would be the one with the highest frequency. And so if we look on here, we can see that the highest frequency was 7. And the mistake that a lot of people make then is writing down 7 as the answer for the modal number of points. But that's just the number of times it occurred. The modal number of points is actually 2. So it's the number of points that had the highest frequency. So the one with the highest frequency then was 2 points. So the next thing we've got to do is work out the total number of points scored. And so what we can do is we can add another column here, which is going to be the frequency. So the value in this column multiplied by the value in this column, which is the number of points. So if I'm going to call this X is the number of points scored, so that then I can label this column frequency times X. So what I would need to do is multiply the number in the frequency column by the number in the points column. So 4 times 0 gives me 0. And then we continue going down this column. So we can see that 3 times 1 is 3. 7 times 2 gives me 14. 3 times 5 gives me 15. 6 times 4 gives me 24. And 5 times 5 gives me 25. Obviously, because we're on the calculator paper, what we would do is we'd use a calculator just to avoid making any mistakes. And if we add this column up then, that will give us the total number of points scored. So we'll just add all these up together, and just so I don't make any mistakes, I'm going to add it up on here. 3 plus 14 plus 15 plus 24 plus 25. And so we've got 81. And that is going to be the total points scored. So we can just write this down here, work out total number of points scored. So it's going to be 81. Question 19 is a question where we've got to make X the subject of this formula, which is Y equals 2X plus 4. So what that means is that hopefully, eventually, we're going to end up with, if X is the subject, X is the one which we've got is equal to something that we need to work out. So this is the bit that we've got to work out here. Currently, at this point, Y is the subject. So the subject is always the one that's on its own equal to something. So I'm going to start off with that Y equals 2X plus 4. And what I'm going to try and do is get the X on its own. So anything that's not an X, I want on the other side of the equals. So what I'm going to do is, first of all, I'm going to take away 4 from both sides. So as long as we do the same thing to both sides of the equals, then we'll end up we're following the rules of these equations, and we've not done anything wrong. Because the reason why we've took away 4 from this side is if we've got a plus 4 and a minus 4, they cancel each other out. And so that would mean that on the left-hand side there, I've got Y minus 4, because now I've just got Y minus 4 there. And on the right-hand side, I've just got the 2X. And now what I need to do is I need to get rid of this 2. Well, what it means there, that actually means 2 times X. So I need to think of what's the opposite to multiplying by 2. And the opposite to multiplying by 2 would be to divide by 2. So what I'm going to do is I'm going to divide by 2 here, and writing it as a fraction like that means dividing by 2. And so I'm going to do the same thing on this side, divide by 2. And the reason for doing that is because multiplying by 2 and dividing by 2 are opposites, then they cancel each other out. And that's just going to leave me with x on its own. And on the left-hand side, sorry, I've got just y minus 4 over 2. And that's it. We've done it. So now looking at question 20, we've got this diagram which shows a square, ABDE. So ABDE, so that's the square. And we've got an equilateral triangle, which is BCD. And what we've got to do is work out the angle EBC. And EBC this is 3-letter notation for an angle. So I'm just going to try and take the bit with E, B and C out on its own so we can see it a bit clearer. So you can see from the diagram E, B and C are like that. So I've just drawn this line and this line. And what we're looking for then is the angle is where the middle letter is. So the angle is this one. So we go from E to B to C, and the angle is what's at the middle. So what we need to do is we need to work out this part of the angle and this bit of the angle. And then when we add them together, so let's say we'll call that one X and we'll call that one Y. So EBC is going to equal this X bit here plus Y. And so the way we're going to work out EBC is work out X and Y separately, and then we're going to add them together and we'll get EBC. So I'm just going to quickly draw this part of our square with X on it. Now, a square has got right angles at every corner. In fact, I'll just draw the whole thing there. So that's our square. And so every corner is a right angle. But this diagonal, so right angle is 90 degrees. But this diagonal is splitting that 90 degrees into 2. So if I divide 90 divided by 2, that actually gives me 45 degrees. So that is 45. And actually X as well is 45. So we've got the X there. X is 45. And now if we're looking at the equilateral triangle, so I'll try and draw an equilateral here. Since you may know what these angles are in an equilateral, and if you know them, it's easy. They're all 60. Because equilateral means for an equilateral, what we've got is all the angles and lengths are the same. So if all the angles and lengths are equal, well, because we know that the angles in a triangle add up to 180, so that would be all these three added up would make 180. Then to find any single one of them, it's just divided by 3 since they're all equal. And 180 divided by 3 is 60. So that's why each one of the angles in an equilateral triangle is 60. It's just 180 divided by 3. And so finally, we're looking for EBC. Well, that was our X value. That was our Y value. So Y was 60. So EBC, it's just a case of adding them together. So it's just going to be the 45 plus the 60, and that's going to equal 105. There we go. So I hope that's been helpful to you. And we will be covering all the rest of the questions. So if you do find it helpful, please give us a thumbs up and also subscribe to our channel. Thanks for watching.